In the last episode, we talked about the 3 lessons that we can learn from the story. It was about a seemingly failed experiment. The experimenters turned it into a working experiment by meticulous troubleshooting using negative controls and by flexible, deep thoughts. The 3 lessons were focused on the importance of negative controls in life science experiments. That was part 1 of the 2-part reflections on the story. Today's episode is part 2. We will talk about 3 more lessons. Overall, the lessons will be beyond negative controls. 2 lessons will be about the importance of a thoughtful approach in life science experiments. How can we be thoughtful? We will talk about the details. And the last lesson will be the most general and the most important. What will it be? Hi everyone, welcome to the Foundational Skills in Life Sciences podcast. I'm your host, Dr. Synaptologica. We discuss the skills that life science scholars learn, use, and improve throughout professional activities. Your benefit is expressed in my motto, learn the skills, enjoy academic life. Last episode. From the episode 19, we have been discussing a real story about a life science experiment. It was one specific pilot experiment that did not work well at first. But the experimenters did not give up. They generated a series of ideas to understand the problem, designed specific negative controls to test the ideas, performed troubleshooting experiments, and finally solved the problem. In the last episode, episode 25, we discussed the 3 lessons we can learn from the story. They were focused on negative controls that played such a prominent and important role in the story. Here are the 3 lessons. Lesson 1 was that negative controls are meaningful and important, like positive controls are. Lesson 2 was that the assumptions of negative controls are critical in determining whether negative controls work well or not. And lesson 3 was that a modified definition of negative controls makes us flexible in the thinking process. Today's episode. The goal of today's episode is to learn more lessons from the story. We will discuss 3 lessons. Under each lesson, there will be 1 to 3 professors' viewpoints. We will give consecutive numbers to the lessons and professors' viewpoints, respectively. We had 3 lessons in the last episode, so today's lesson will start from number 4. But we did not have professor's viewpoint in the last episode, so it will start from number 1. Our discussions today will cover the importance of a thoughtful approach in life science experiments and a general mindset about doing experiments. Lesson 4. Thoughtful approaches to life science experiments. In previous episodes about our story, we have seen the individual ideas and steps of how the experimenters explore the problems in their pilot experiment. One important point was that the experimenters realized a critical fact. It was that the composition of 2 culture media were different. That is, the serum was present in the old culture medium, but it was absent in the fresh one. This point was mentioned in the professor's viewpoint section of the episode 23, but let's discuss it a little deeper here. It was challenging to notice the fact about the different compositions of culture media. This is because the entire experiment was composed of different time periods which required different protocols. The experimenters connected different protocols together to perform a single experiment. To be exact, there were 4 experimental periods that were described by 4 different protocols. The first period was the culture period. The experimenters prepared a cell culture and maintained it. It needs the experimenters to prepare a special culture medium directly associated with the cell type and the experimental purposes. The second period was the stabilization period. The experimenters introduced this period to stabilize the cell function in preparation for the following chemical treatment and functional measurement. The third period was the treatment period. The experimenters applied active or inactive chemical compounds to the cultured cells. And the last period or the procedural step, was the measurement of a cell function. Each of these 4 periods or procedural steps needs special media, special maneuvers, and uses of special equipment. And the 4 protocols corresponding to the 4 periods or procedural steps were derived from different sources. In this specific case in our story, one type of culture medium, that is the old culture medium, contained serum, but the other type, that is the fresh medium, did not. And the mismatch between the 2 culture media created a problem. In other cases in other research groups, one part of a protocol can affect the condition of the experimental system in another part of the protocol. One critical point in our story was that the overall protocol for the entire experiment did not specifically say that the serum would be removed during the culture medium exchange. The overall protocol simply instructed to replace the old culture medium with the fresh culture medium. At first, the experimenters were not aware of the fact about the serum. Simply, they did not pay attention to the serum. A practical problem was that the experimenters in our story kept the protocols in the following 4 documents, and these documents were scattered as printout papers. One protocol document described how to perform cell cultures. Another protocol document described the composition of cell culture medium for the culture period. This medium included the serum and corresponded to the old culture medium that we have been talking about. It also described how to prepare the culture medium in detail using tens of chemical components. Still another document described how to keep the cells in the stabilization period without stimulation. It also described the composition of the fresh culture medium. This fresh medium did not include the serum. One more document described how to measure the cell function, including how to use the function measuring equipment and how to analyze the recorded data. Eventually, the experimenters accessed all the documents that described the protocols. They checked all the contents, and they managed to piece together all the information. They carefully reevaluated all aspects with a critical eye. Then they found a mismatch between 2 protocols, covering 2 consecutive experimental periods. They identified a difference between the 2 culture media, old and fresh. As I mentioned in episode 23, it is often challenging to question a protocol and revise the thinking behind the protocol once an experimenter believes that a protocol should work fine. But the experimenters reevaluated all aspects of their protocols with a fresh mind. I think that the experimenters' efforts were commendable, and their success in troubleshooting was based on their flexible thoughts and a healthy dose of skepticism. Our story tells us that it is important to consider all aspects of an experiment. The experimenters showed their thoughtful thinking processes. They avoided being dogmatic and narrowly minded. They were not limited by what lay right in front of them, for example, written protocols prepared by previous laboratory members. One example happened to be the media composition in our story, but in other cases, critical things to think about can be anything else in an experiment. Seemingly insignificant details can have a significant impact on the results. Lesson 4 is that thoughtful thinking processes are important. Lesson 4 continued. It is easy to say, be thoughtful. But when we think about it, be thoughtful is very vague. How can we be thoughtful? Are there some practical ways for becoming thoughtful? Let's think about how to become thoughtful as a life scientist. I will give you 3 professors' viewpoints. They are all my personal viewpoints, but I believe that they will be important to you. At least, please listen to them and think whether you can adopt the views. If you think they are good, please give them a try and implement them as your foundational skills in life sciences. Professor's viewpoint 1, how to be thoughtful with a healthy dose of skepticism. We have already discussed 2 actions about negative controls. Let's use them as an example. Please remember that in our story, the experimenters were creative in thinking about the negative controls. They used the negative controls to find that the entire experimental system was not working well. And they also used negative controls to examine the potential causes of the problem, generate new ideas, test those ideas, and create a meticulous protocol. In a way, they used negative controls effectively as scientific detectives. One action about negative controls was to carefully examine the two assumptions of negative controls, Assumption 1 and Assumption 2. Negative controls need to satisfy either of the two assumptions to be effective. The other action was to always keep in mind the modified definition of negative controls. It says that even if a negative control is thought to work, there's a chance that it might not. These two actions will change our mindset about how to evaluate the experimental system. They will remind us that in a new experiment, it will be helpful to assume that not much is known about the negative controls and the overall protocol. Even in a familiar experiment, they will emphasize the concept that anything unexpected could happen in experiments. Summarizing these two actions, that is, examining the assumptions and considering modified definitions of negative controls, I would say that my keyword is a healthy dose of skepticism. Question the assumptions. Routinely look for potential explanations beyond initial ideas. Question the seemingly obvious steps. As I mentioned in episode 18, it is good to approach any experiment with the mindset that anything strange and unexpected could happen. Let's be careful, flexible, and open-minded about potentially hidden factors or problems. A little bit of skepticism will be helpful. The next two professors' viewpoints will be beyond negative controls. Professor's viewpoint 2, how to be thoughtful with a viewpoint from experimental targets. When we think about experiments, we usually take a viewpoint from the experimenters. This is natural because we do the experiments, we observe, and we read the data. We work on the experimental targets such as molecules, cells, tissues, organs, whole animals, or human subjects. We take actions on them. But I would like to introduce to you what I often do when I think about experiments. I try taking a viewpoint from the experimental targets. For example, let's assume that we are working on cells, like the Nobel Prize Laureates in Physiology or Medicine 2023 in our milestone article 1. Then we would imagine that we become much smaller and we become the cells that the experimenters are working on. Then let's think about what will happen to us during an experiment. This is what I often do when I do experiments myself. For example, what will we experience if a culture medium is changed abruptly with a strong turbulent flow? Solution turbulence can be felt differently depending on how large or small we are. Even when I try changing the solution very gently and very slowly as an experimenter, the flow can be felt extremely strong at a small single-cell level. Does such a turbulence affect the cells, for example by activating a stretch-sensitive mechanism like mechanoreceptors on the plasma membrane? What will we experience if the temperature of the culture medium that bathes us changes abruptly? For example, when a warm culture medium is suddenly replaced with a cold culture medium? How about in our story that we have been discussing in these episodes? From the viewpoint of the cells, or we, need the serum for happy survival. And the serum has been around us throughout the 1-week culture period. Then on the experimental day, the serum was suddenly removed at the start of the stabilization period without any warning to us. Serum is one of the critical components in the culture medium, that is, in our cellular environment. It is understandable that when the serum disappears suddenly from our environment, something about cell functions, or our functions, could drastically change in response to it. Anything could happen under this situation, although we might not know the mechanism. By taking a viewpoint of the cells, I try understanding the impacts of my hand maneuvers and procedures in the protocol on these cells. We talked specifically about cultured cells in our story, but I think that the same comment will apply to any other targets of experiments, for example, the tissues, animals, or human subjects. For example, suppose we are testing the behavior of an animal. If we, as experimenters, give a lot of noise and vibration when we transport the animals from one place to the testing room, the animal behavior could be affected very much if the test is conducted immediately after the transport. There's not enough time for the animals to relax before the test and go back to the resting level. If we, as experimenters, have perfume on our bodies, the smell can affect the animal behavior. They might not like the perfume. An animal cage in an animal room has animal bedding. It is the material on which the animals stay, lay, and sleep. If an animal bedding is changed and renewed immediately before a behavioral test, the animals might not have time to get used to it, and the animals might not feel comfortable, and their behaviors could be affected. So I like to consider an experiment from the viewpoint of the experimental targets. It will help us visualize and experience any possibility of what happens before and during the experiments. This is especially helpful in troubleshooting experiments. This is one of my ways to train my mental dexterity, in addition to my manual dexterity, such as my hand maneuvers and hand-eye coordination. Viewpoints from experimental targets can give you thoughtful approaches. Professor's Viewpoint 3, How to be Thoughtful with Frank Discussions. The last professor's viewpoint about how to be thoughtful is a more general comment. It is to share information, ideas, and valuable thought processes within a single laboratory or a lab. In many cases, a laboratory will be best unit for sharing information and ideas. A larger body, such as 2 or more laboratories in collaboration, or a bigger institution with tens or hundreds of laboratories, could also work. But I personally found that it is difficult to implement and maintain efficient mechanisms of sharing information. So, to start with, a single lab would be great. I can think of at least 3 practical ways of sharing information, ideas, and valuable thought processes in a lab. The first practical way is that the principal investigator actively reminds the lab mates of the importance of sharing. Quick note. The principal investigator, abbreviated as the PI, is a person who is responsible for a grant and for a research project funded by it. A PI is most often a professor, that is, an assistant professor, an associate professor, or a full professor. Another quick note. Lab mates, or lab members, are usually undergraduate students, graduate students, postdoctoral researchers, and technicians. There can be other trainees too, such as research assistant professors and visiting scholars. In this first practical way of how to share information, the PI sets the mindset in the lab. The PI reminds the lab mates of the importance of sharing. The PI reminds them of the possibility that any strange thing can happen during an experiment, so it is important to pay attention to details and to be flexible in thinking. You are lucky because I'm serving as your friendly mentor and collaborator. You are hearing such a mindset from me. This will prepare you to be a thoughtful researcher. I hope this will be a great mindset shift for you. The second practical way of sharing information is by sharing documents. Keep all the related documents in an easily accessible place. This way, every member can access them and share the written information whenever a member wants to do so. Practically, the documents will be electronic files, and they are saved in a shared folder in a computer network. I will give you 6 examples of the documents. Protocols, such as the bulleted instructions about what to do and how to do it at individual steps, from the start to finish of an isolated part of the experiments. Compositions of solutions, list of all equipment, including vendor names and product numbers, list of all pieces of software, including vendor names, product numbers, and version numbers, user's manuals for equipment and software, list of all chemicals with properties, for example, vendor names, product numbers, lot numbers, and purchase dates. If they're antibodies, the included information will also be the source antigens, animals in which the antibodies were raised, whether they are monoclonal or polyclonal antibodies, and so on. There can be more documents with specific purposes. Sometimes you might want to merge the related documents into one document for your convenience. In such a case, I would recommend you create a separate personal merged document without changing the source files that every member will access. This is because other members will do other experiments different from yours, and those members will need different combinations of documents from what you want to use. So it is best to keep individual shared documents intact. The third practical way of sharing information is by creating opportunities that are friendly to lab mates. The best example is a lab meeting. A lab member will present a progress report. There, the PI will promote the importance of discussing the experimental details as a whole group. The progress report should include not only the successes, but also the failures. If the report includes failed experiments, discuss the reason why they failed. Somebody could point out some ideas about why and how they happened, or some hidden facts, or some previous experience. In my view, the key principle is that the PI welcomes flexible and frank discussions, silly and crazy ideas, without any worry about making mistakes in discussions. We can learn a lot from such opportunities. In our story, the experimenters could notice that the overall protocol had an intrinsic problem, and they solved it with flexible ideas in the end. That was possible because they enjoyed discussions. This is the end of Lesson 4. Again, Lesson 4 was that thoughtful thinking processes are important in life science experiments. Lesson 5. Hidden thought processes behind scientific research. It will be helpful for us to pay attention to the hidden thought processes behind scientific research. This is because they give us a deeper understanding of experiments. Let me explain. In our story, we saw that the experimenters thought deeply. They formed and tested 4 logical troubleshooting ideas, each building on the previous one. They designed specific negative controls for each idea. They used the negative controls for identifying problems, and they finally solved the problem and upgraded the protocol. I think the entire series of thought processes was an impressive achievement. Yes, in our story, it was used only for troubleshooting the pilot experiment that did not work originally. But with this successful achievement, the experimenters could finish their main experiments later, and they could examine the effects of test chemical compounds on the specific function of the cells. In addition, we saw that those 4 ideas were creative, and the ideas reflected the sequential and logical progression of the experimenters' thought processes, and each process was based on the solid finding of the previous one. This type of thought processes is necessary not only for troubleshooting experiments, but also for other aspects of experiments. For example, how to design an experiment, how to understand non-reasonable experimental results, how to bring a project forward, and importantly, how to bring an end to a project. These hidden thought processes are related to critical decision-making. Overall, we have witnessed the extensive effort and strategic thinking involved in scientific research. They are very valuable experience in a lab. There are two main reasons why I wanted to show these processes to you in our episodes. The first reason is because some people might not know that a single experiment can be based on a long series of troubleshooting and refining experiments. It is very helpful to know that an experimental design is almost always based on a complex and deep thinking process. Such a process will give us valuable insights into how to troubleshoot and design experiments in general. Now, in relation to the second reason why I wanted to show these processes to you, let me ask you a question. Have you read this type of thought processes in published papers? No. Most likely, you will not see them. The second reason why I wanted to show these thought processes to you is because I wanted to let you know that these rich thought processes do not appear in published papers. In other words, those thought processes usually take place behind the scenes. They're often hidden in published papers. Which part of the thought processes will be described in published papers then? Some parts of the thought processes can be published in methods papers. In methods papers, the authors explain the details of experimental protocols, usually the existing protocols, or sometimes new protocols. And the description can be, for example, if you do it in a way other than the way that we described, your experiment might not work. But the descriptions are usually limited only to a small number of key points of the thought process. In contrast, in primary research papers that present new findings and new ideas, the authors will usually describe only the final, revised, working protocols. So the described protocols tend to be practical and already well thought out. The traditional way of writing the methods section of those papers is to describe the protocols in the most concise way. The essential features are included so that the other research groups can reproduce the experimental results. But the protocols will be described without any detailed explanations. The authors will intentionally exclude the explanations and comments related to all the efforts of troubleshooting and all the efforts of establishing the working protocols. So these critical pieces of information are hidden from normal readers. When normal readers read papers, it might be difficult for them to imagine that this type of extensive efforts and strategic activities are hidden behind the seemingly perfect experimental protocols. I wanted to share this information with you, again because of two reasons. Firstly, because knowing that there is a complex and deep thinking process is very helpful. And secondly, because such thinking process is not commonly available in primary research papers. So, lesson 5 is that it will be helpful to pay attention to the hidden thought processes behind scientific research. Professor's Viewpoint 4, Reading Between the Lines of Research Papers. There's an added bonus to the lesson 5. Once you start paying attention to the hidden thought processes behind scientific research, you will start building your ability to read between the lines of research papers. Here's how your mind will change. You will start appreciating the thought processes behind research in your lab. At first, the thought processes will be invisible to you in papers. But this opportunity will give you an important insight into what you can see and what you cannot see in papers. This experience will make the paper reading interesting and enticing. This will be especially true in methods and results sections. These sections are directly related to experiments. Behind these sections lie all the thoughts about designing experimental protocols, troubleshooting experiments, finding optimal parameters for experiments, executing experiments, and analyzing experimental results. So pay attention to stories like ours in recent episodes. Enjoy listening to them. The more you hear, the more you think, and the more you experience these stories, the better your thought processes will be. After these, you will slowly become able to read the things that are not explicitly written in published papers. So you will slowly become able to read between the lines. This is deep and fun reading. Next, let's talk about the last lesson. Lesson 6, staying perseverant, focused, and optimistic. The experimenters in our story faced many problems, but they did not give up. They persevered and solved the problem. Life science experiments usually take many days, weeks, and months, sometimes over many years. As we have seen, there can be many problems, so it is easy to give up. Our lesson is simple, but this may be the most important lesson. Lesson 6 is to be perseverant, stay focused, and stay optimistic in any experiment. Professor's Viewpoint 5. How much behind-the-scenes experiment is necessary? We are doing the behind-the-scenes experiments all the time. They include pilot experiments, troubleshooting experiments, and experiments to find the best parameters. They will not show up in published papers, as we have discussed, but they are necessary for establishing and refining the experimental protocols and for setting up the experimental system. There will be many of these behind-the-scenes experiments, especially when we work on new experiments. I would say we will spend 90 to 95% of the experimental time in these behind-the-scenes experiments. After the protocols are refined, we will spend the remaining 5 to 10% of the experimental time in obtaining the real data. So do not despair, even if you need to spend much time in behind-the-scenes experiments. The more you do those experiments, the better your real and final experiments will be. This is the end of the main content today. Summary. We have discussed 3 lessons, continuing from the 3 lessons in the previous episode. Lesson 4 was that thoughtful thinking processes are important. Professor's Viewpoint 1 was about how to be thoughtful with a healthy dose of skepticism. Professor's Viewpoint 2 was about how to be thoughtful with a viewpoint from experimental targets. And Professor's Viewpoint 3 was about how to be thoughtful with frank discussions. Lesson 5 was that it will be helpful to pay attention to the hidden thought processes behind scientific research. Professor's Viewpoint 4 was about reading the lines between research papers. Lesson 6 was to be perseverant, stay focused, and stay optimistic in any experiment. And the Professor's Viewpoint 5 was about how much behind-the-scenes experiment is necessary. These lessons are all good lessons to learn. They will serve you well when you do experiments yourself. They will serve you well too when you read papers by other researchers. I'm always impressed by how much we can learn even from a problematic and non-working experiment, especially if the story ends with how the problem was solved later. Your action. I'm interested in stories from you about life science experiments that did not work at first, but that worked well later after troubleshooting. Could you share those stories with me? If you are doing experiments, or if you did experiments, please think about them. If you have not done any experiments before, please think about the stories you heard about those problematic experiments. I welcome any story from you. I strongly believe that we can learn a lot from our mistakes, either in designing, executing, or interpreting experiments. Our knowledge about mistakes can help us become better prepared and careful in our own experiments. In other words, stories about mistakes will train our mental dexterity. Please contact me by email. My email address is ideas@synaptologica.com. Thank you for joining me in today's episode of Foundational Skills in Life Sciences. I'm Dr. Synaptologica. I'll see you soon. Bye for now.